All right, guys, are there any questions regarding the assignment before we get started today? What we're looking at today is our function operations of functions. Now, there's four main ones that we're going to look at today. And that's addition, subtraction, multiplication, and division. So I would mainly get the definitions down. You don't necessarily have to write the examples down. So our first one with addition, f plus g of x. So when we say this, it's f plus g of x is the same as f of x plus g of x, adding the two functions together. Subtraction, f minus g of x is the same as saying f of x minus g of x. F times g of x is the same as f of x times g of x. And lastly, f divided by g of x is the same as f of x divided by g of x. So this is a way to make the notation a little bit simpler. Now for any of these here, we're not going to be so much worried about the domain and range. We're just going to mainly focus on the operations themselves. Because, no, we don't have to, because we're going to go through some examples here. So, not focused on the domain, but let's f of x be 3 times the square root of x, and g of x be negative 10 square root of x. Find f plus g of x, and then evaluate it when x is equal to 4. So we're looking for f plus g of x. F plus g of x. Well, f plus g of x is the same as saying f of x plus g of x. Well, for us here, f of x is what? 3 square root of x. And g of x is negative 10 square root of x. Now at this point here, we can drop the parentheses. So we have 3 square root of x. Well, our plus negative 10 square root of x is just going to be minus 10 square root of x. Can we combine these two? Can we actually subtract these two? Yeah, since they both have square roots, and what's inside the square root is the exact same, we can do 3 minus 10, which is negative 7 square root of x. So for us here, f plus g of x is negative 7 square root of x. Questions on this here so far? So that's the first part. Then it wanted us to evaluate when x is 4. So what that's saying is that we want to find out what f plus g of 4 is. We're replacing x with 4. Now we could go through the exact same thing we just did, having f of 4 plus g of 4, and going through all these steps here to figure out what it is. However, I know that f plus g of x is negative 7 square root of x. So I can use that and say this is equal to negative 7 square root of 4. It will give us the exact same thing, but with a lot less steps. Welcome. I do. Welcome. Well, the square root of 4 is 2. Negative 7 times 2 is negative 14. So f plus g of 4 is negative 14. And that's it. Both. So it wanted us to find f plus g of x and then evaluate when it's 4. We don't have to state the domain. The values of x that we can plug into the function. And for both of these here, the domain would be the values of x that are greater than or equal to 0, because we can't have a negative inside of an even root, so it has to be greater than 0. But I'm not too focused on the domain for these here. That would be next chapter. Let's look at one more of this here with addition. So we're going to look at one more addition, then we'll move on to subtraction. So f plus g of x. This is the same thing as saying f of x plus g of x. F plus g of x is the same as saying f of x plus g of x. Well, they've told us f of x for this one here is 5 square root of x plus g of x is negative 8 square root of x. Now we can drop the parentheses and simplify them, but that's just going to tell us that we have 5 square root of x. And the plus negative 8 square root of x is the same as just saying minus 8 square root of x. And since both of these terms, 5 square root of x and 8 square root of x, both have just the square root of x, we can actually subtract the numbers in front. 5 minus 8 would be 3 square root of x. So f plus g of x is negative 3 square root of x. Any questions on how we found f plus g of x? Now that we've found out what f plus g of x is, don't care about the domain, we want to evaluate the sum when x is 16. Or see what f plus g of 16 is. And all that means is in our negative 3 square root of x, we're replacing x with 16. And the square root of 16 is 4. Negative 3 times 4 is negative 12, telling us that f plus g of 16 is negative 12. And that's it. Any questions on any of this here? Any questions on any of this so far? How do we feel about addition? It's not that bad. Really, we're just adding the two functions together. Now, they don't have to be radicals. We can have any type of function. We're just adding the two together, combining like terms.
Will they put like 5 square root of 3?
5 square root of 3 and negative 8 square root of x. Yeah, so this is a 3. I mean, we can, but it would mean that this here would be the final answer.
Oh.
Because since they're not the same, we don't have the same radical and terms inside, that's as far as we can take it. Then in the other one, we would plug 16 in just for the 1x and simplify from there, which would end up giving us 5 square root of 3 minus, because it'd still be 4. This here would be our answer. because we can't combine the 5 square root of 3 and 32 unless we turn 5 square root of 3 into a decimal and go from there. Does that make sense? Now we're going to look at subtraction. Now this time they didn't give us radicals, they gave us polynomial expressions, but it still works the same. So we're looking at f minus g of x. And f minus g of x is the same as saying f of x minus g of x. And for this here, this problem here, they told us f of x is 3x cubed minus 2x squared plus 5 minus g of x, we're going to replace it as x cubed minus 3x squared plus 4x minus 2. Any questions on this so far? So up to this point, has this been any different than what we did on the first one? No, except it's subtraction instead of addition. That's the only difference. Then our next step, we can drop the parentheses and say 3x cubed minus 2x squared plus 5. But I can't just drop the parentheses of the other. We have to apply that negative to every single term over here. So we'll have negative x cubed. The negative 3x squared is going to become plus 3x squared. The positive 4 is now negative 4x. And the positive 2, or negative 2, is now positive 2. Because we're saying we're subtracting it. We're applying that negative to every term. And finally, combine like terms. 3x cubed minus x cubed is 2x cubed. Then we go to the next one, negative 2x squared plus 3x squared is going to be plus x squared. We don't have an x term in the first in f of x, but we do have negative 4x in g of x. And lastly, we have 5 plus 2 is plus 7. So f minus g of x is 2x cubed plus x squared minus 4x plus 7. That's it. Now, they did ask us to evaluate it when x is negative 2. So that's just telling we have 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. Now we could do this out by hand, multiplying this out, or we can just do this in a calculator. 2 parentheses, negative 2 cubed. Plus negative 2 squared. What's it? Minus 4 times negative 2 plus 7. If I remember right. Which gives us 3. Yep. So f minus g of negative 2 is 3. And on the first two, we could have plugged those straight into the calculator and gone from there. And especially if it is a square root, I would use the 30xs, the yellow calculator, of the graphing. They work better with square roots. But any questions over any of this here? If we feel good with this here. Let's look at one more of these here. And then we can move on, because I don't think that the addition and subtraction is too much. I think we feel good with these here, yes? So for this here, f minus g of x. So this is the same as saying f of x minus g of x. And we're going to input our functions in. So they told us f of x is all this here. So we replace f of x with 2x cubed plus 4x squared minus 8x plus 4. We replace g of x with its function. 3x cubed minus 5x squared plus 6x minus 9. Now for our first function, f of x, since there's no sign in front of those parentheses, nothing changes. But the second one, we have to apply that negative to every single term. So that gives us negative 3x cubed. And we have plus 5x squared minus 6x plus 9. Every term in g of x sign is going to flip. Each one that's positive is now negative. Each one that was negative is now positive. Combine like terms. 2x cubed minus 3x cubed is negative x cubed. 4x squared plus 5x squared is plus 9x squared. Negative 8x minus 6x is negative 14x. And lastly, 4 plus 9 is plus 13. So our f minus g of x is negative x cubed plus 9x squared minus 14x plus 13. Now we need to determine what this function is when x is negative 1. So every place where there is an x, we're going to replace it with negative 1. Plus 9 is negative 1 squared minus 14 times negative 1 plus 13 is 37. Any questions on addition or subtraction? We good with these here? Multiplication. So our product, f times g of x, is the same as saying f of x times g of x. Now for us here, we can replace f of x with its function, which is x squared. And we can replace g of x with its function, square root of x. And if we multiply these together, we get that's it. I mean, we could make them one single function, but to do that, we would just change the square root of x to x to the 1/2. When we multiply like bases, we can add the exponents, and we could go from there. So I had a feeling the textbook would say that. I'm going to take this. I will take this as your answer, because the textbook, and kind of as some would say, we would change square root of x to x to the 1/2, or radical to exponential. And then if we add, because then we can add those two together, x to the 5/2. I'm fine with this here. Yeah, because it's not any more, because x to the 5/2 is not any better than x squared times square root of x. They are the exact same thing. Any other questions on how we did the multiplication? Now we also need to evaluate it when x is 9. So replacing each x with 9. So we have 9 squared times square root of 9. Can we take the square root of 9? Nicely, yeah. So we can put it in the calculator, and really we could put it in either calculator. You get 243. Because if we work this out, 9 squared is 81. Square root of 9 is 3. And 81 times 3 would be 243. Or we could just plug it in and see that it is 243. Questions on this here? You ready for the next one? F of x is x cubed. G of x is square root of x. Find f times g of x. So f times g of x is the same as f of x times g of x, and we can replace our functions here. F of x would be x cubed. G of x is the square root of x. And if we multiply them together, we get x cubed times square root of x. Now we do need to find out what f times g of 4 is. Well, we're just replacing every x with 4. So we'd have 4 to the 3rd times square root of 4. Because we can say 4 to the 3rd, which is 64, and the square root of 4 is 2, and 64 times 2 is 128. And there's a good number that are still smarter than I. Hawking, Stephen Hawking. He's not. The next thing we're going to look at is division, dividing 2. F divided by g of x is the same as saying f of x divided by g of x. And we'll replace f of x and g of x with their respective functions. So f of x is 6x, g of x is x to the 3/4, So we get 6x divided by x to the 3/4. Now we will simplify this here, because if we have like bases, x and x, and they're being divided, we subtract the exponents. Because if we multiply like bases, we add the exponents. So here we would do x to the 1. Come on. 1 minus, okay, now minus 3/4. And 1 minus 3/4 is 1/4. So f divided by g of x is 6x to the 1/4. Any questions on how we found this here? Now we need to find out what f divided by g of 16 is. So we're just going to replace x with 16. Now we can plug this into a calculator. We can say 6 times 16 to the, and I'll go back, and it is 12. Okay, so we're looking for the 4th root of 16. So what number times itself 4 times? Because 2, yeah. So 16 to the 1/2, square root of 16 would be indeed 4. But this is also questions on this here. Let's look at this one here. All right. F divided by g of x is the same as f of x divided by g of x. F of x is 4x. G of x is x to the 2/3. Now, just like the last one, we can divide our two variables. Because whenever we have like bases being divided, we subtract the exponents. And 1 minus 2/3 is 1/3. So our f divided by g of x is 4x to the 1/3. And we do need to evaluate this when x is 27. So that tells us that we have 4 times 27 to the 1/3. And we can plug this in a calculator. We can say 4 parentheses 27 to 1/3. Ironically, the last two have been 12, because 1/3 of 27 is 3, because 3 times 3 is 9, 9 times 3 is 27. And then 4 times 3 is 12. So it just worked out nicely that way. Any questions on this here? Any questions on multiplication, addition, subtraction, or division? Do we feel comfortable with these here? Because even with these here, x to the 2/3, because those are the same, they have the same exponent, we can add or subtract them. it doesn't make a difference.
Miss Christine, if you could please come to the office. Miss Christine, please come to the office. Thank you.
And guys, that is it. So your assignment is on page 275, 3 through 11 odd, so 5 problems. So you will have to find, so for the first set with addition subtraction, it's asking you to add and subtract the functions, and then evaluate the addition and subtraction for the given value. The next set is multiplication division, so you're doing the same thing. You're multiplying, dividing, and then evaluating it for the given value. So 3 and 5 are addition subtraction. Okay. Yep. I'm going to change this one little bit, guys. 3 through 9. No. I'm doing 3 through 9, so you're doing 2 with addition, subtraction, 2 with multiplication, division. So for problems 3 and 5, find f plus g of x and f minus g of x. And then evaluate both of those for the given value of x. So if you notice 3 and 5 have x equals at the end, so that's the value you plug in. So, yeah, you do not have to find the domain for any of them.